AMD versus Intel. Which one to use? In the last video, I made an introduction to another ASRock motherboard to be part of an old PC configuration. This was an unusual motherboard with AGP and PCIe Express slots along with DDR1 and DDR2 memory support. There were some minor problems with broken capacitors, but it was quickly resolved. Currently use Intel Pentium 4 model 630 with a simple stock cooler. Similar to previous, the first ASRock motherboard I have is an AMD configuration with Athlon XP model 2600 Plus processor, mounted with a third-party cooler, supposedly quieter and better performing than previous stock cooler. The goal for this video is to compare benchmark results between these two configurations to see what will be mainly used. But first, let me describe processors a bit more. The AMD Athlon XP 2600 Plus is a single-core processor using the Barton architecture with 512 KB of L2 cache and clock speed at 1.9 GHz. AMD is making the Athlon XP on a 130nm production node using 63 million transistors with TDP of 68 watts. The multiplier is locked, which limits overclocking potential. The Intel Pentium 4 630 HT, also a single-core processor using the Prescott architecture with 2 MB of L2 cache and clock speed at 3 GHz. Intel is making the Pentium 4 on a 90nm production node using 169 million transistors with TDP of surely higher 84 watts. It also has locked multiplier, but with hyperthreading technology it can process two instruction streams in parallel. Like I said on the beginning, this will be a comparison, not competition or a duel. Processors are in year-and-a-half gap, and by the description, Intel is a head start winner. But some things are big disadvantages to both CPU. Starting with Athlon XP with 69 watts TDP, the big problem is with power consumption. This CPU requires a power supply unit with stronger 5V rail than usual. Today is a challenge to find that kind of power supply unit unless you attached an overkill 1000 plus watts power supply unit for a merely 68 watt CPU. Alternative is to find a proper socket 8 motherboard with 12V connector. You can attach then any other non-specific power supply unit. Again with problems, these motherboards are more rare and more expensive than power supply unit itself. Now with Intel CPU, these problems are non-existent. The problem is inside CPU architecture. Prescott, or someone call it press hot, what is known as a very hot CPU, its raw strain demands a good power supply. In return, it gives good performance. It will give a better ones if only it had higher instructions per cycle value because of very deep 31 stage pipeline. Difficult to explain. For testing, both configurations will use the same Radeon 9 600 XT with 256 MB and the same single channel 1GB RAM module. In this case, 9600 XT sounds like a handicap, bottleneck graphics card, but it's the strongest AGP card I own. Now we know the details, so let's see what we have in the benchmarks. Let's start with popular benchmark 3D Mark from 2001 and later 2003. This was a synthetic benchmark and a bragging tool among gamers. It drains GPU features to the max, but we can see what will CPU bring to improve results. In this case, Pentium 4 is ahead with 17% higher results than Athlon XP. For 3D Mark 2003, GPU is already considered a bottleneck. The difference is merely 6%. Next one is kinda underrated, Draken Order of the Flame from 1999. Beautiful graphics demands a stronger GPU and CPU to run the game in high details. The first test is with details turned off, shows us Pentium 4 reaching stunning 36 up to 60% higher results. To be fair, Athlon XP still shows us high FPS around 145. The second test is with all details turned on, such as high textures, polygon counts, lighting and shadows. Pentium 4 shows us a bit smaller results, from 30 to 46%, and Athlon XP reaches maximum 106 FPS in 1024p resolution with tiny micro-stuttering. Quake 3 Arena from 1999 was a groundbreaking first-person shooter. The game also demanded high CPU and GPU, but not for graphics, only for smooth gameplay. The first test is with high details, up to 1024p resolution, to see how it will run in other games that used Quake 3 engine. Pentium 4 shows better results in lower resolutions, up to 44% higher FPS and just a 5% in high resolution. To make the second test more heavier, anti-aliasing and isotropic filtering are set to value 2x. Now the results makes difference only in lower resolution, up to 60%, while higher resolution reached GPU limits and shows us nothing but a margin of error. Serious M, the first encounter, the gem from Croatia, a fast-paced slaughterfest, accepts no issues from micro-stuttering if you don't want to miss your target in a overcrowded monster dance party. The game is set to quality video mode, no anti-aliasing and isotropic filtering, tested in 3 different resolutions. Although it's not meant for benchmarking, it shows us similar results like Quake 3. In lower 480p resolution, the difference in FPS is 17 to 31%, both CPU good results in low and high peak FPS. In 600p we have the difference 9 to 20%, and in 768p only low peak shows 15%, while high peak FPS a tiny 3%. Overall, everything is highly playable except for our last test. Doom 3 from 2004 is an oversized bite for our 9600 XT, but if we set to low details and lowest resolution, the game can still be playable. In 480p, the difference is noticeable 22%, in 600p unnoticeable 9%, while in 768p there is absolutely no difference. Just for fun, I did the test in high details to squeeze the very last power atom. As expected, only in 480p we can see some minor difference, only 11% or 5 FPS, 600p 7% or 3 FPS. Again, no difference in 768p. And that's it. Both configurations have its own value. From now on, Athlon XP will be used for Windows 98 and Pentium 4 for Windows XP. A small upgrade will bring a few more FPS to make value even higher, starting with DDR2 dual channel RAM modules, later more powerful and cooler Pentium 4 with Cedar Mill architecture. Thank you for watching, see you again soon.